Determining the need for fuse disconnects depends on several factors. While it is true that safety switches without fuses typically have fault ratings below 10 kA, the need for fuse disconnects for 480-volt loads relies on understanding fault current levels, switching characteristics, and code requirements. Firstly, fault current levels need to be determined. One must determine the available fault current at the point of installation. If the fault current exceeds the safety switch's rating, a fuse disconnect is required to interrupt the excessive current. Secondly, switching characteristics are also important. Unlike circuit breakers, safety switches are not designed for automatic interrupting. They require manual operation to open or close the circuit. In the event of a fault, a fuse disconnect will provide faster and more reliable fault interruption than a safety switch without fuses. Thirdly, local electrical codes may require fuse disconnects for certain types of loads, such as motors or lighting panels. Refer to the applicable electrical code for specific requirements. Lastly, the consequences of a fault should also be considered. If a fault in the load could result in hazardous conditions or equipment damage, a fuse disconnect is a prudent choice to limit the potential risks. In general, it is recommended to specify fuse disconnects for 480-volt loads to provide a higher level of protection against faults and ensure reliable circuit interruption. The available fault current exceeding the safety switch's rating means a fuse disconnect is important. Additionally, if the load requires automatic fault interruption, a fuse disconnect is needed. If code requirements mandate their use, a fuse disconnect is also needed. Finally, if the consequences of a fault are severe, a fuse disconnect is necessary. A fuse disconnect provides faster and more reliable fault interruption than a safety switch without fuses.